Hi everybody. So now we are moving on to our next lesson, and that is going to be about literal equations and formulas. And our goal is to rewrite and use literal equations and formula. Now before everything else, we need to define what a literal equation is. So a literal equation is an equation that involves two or more variables, okay? So let's begin with a sample problem on rewriting a literal equation. So let's say we have a situation wherein you are ordering pizzas, and those pizzas are for $10 each, and sandwiches for $5. So you have a budget of $80. How many sandwiches can you buy if you buy 4 pizzas or 5 pizzas? So given this model of 10x plus 5y equals 80, how will we find the number of sandwiches? So first thing, as you can see here, we have two kinds of variables, okay? We are so used to just having x. And here we have two of them. We have x and y. We have x and y. And we have 2 items that we need to buy. How do we know which one is the variable representing the pizza, which one is for the sandwiches? So if you're going to take a look, the clues are coming from the price of each item. So as you can see, the pizza is for $10, and between x and y, 10 is multiplied to the number of x, so that is the number of pizza. This is now your x value, which means sandwiches, as you can see, 5 times y, so 5 is the price of every sandwich, and so our sandwich is going to be our y value, okay? And so how do we solve for this? So we are looking for the number of sandwiches, which means we need to replace the value of our pizza. So the first situation is, what if you bought 4 pizza, okay? So we will replace the x with 4. So that will be 10 times 4 plus 5y equals 80. And we know that we can solve this equation since we only have one variable now. So 10 times 4, that's going to be a 40 plus 5y equals 80. We need to isolate our y, which means we have to subtract 40 first on both sides, which now gives us 5y is equal to 40. And to isolate our y, we need to divide by 5 on both sides, and so it means we need, or you need to buy, you will be able to buy 8 sandwiches if ever you got 4 pizzas, okay? So why don't you try the other part of the problem we're in? What if you bought 5 pizzas? How many sandwiches will you be able to buy? Go ahead, try that. So if you are able to solve for the number of sandwiches, you will be able to buy 6 sandwiches if you bought 5 pizzas using this model, okay? So let's have the next example. So in this case, we have an equation 4 equals 2m minus 5n, and we need to solve for the value of m. And so what will be the values of m if we replace the n with -2, 0, and 2? So go ahead, try this one out and see what different values of m we can come up with. So as you can see, the values of m differs when you replace n with different values. If n is equal to -2, m can be -3. If n is 0, it's going to end up being 2. And if n is equal to 2, then our m will be equal to 7. Okay? So let's continue with the next example. Now on this case, for this case, we are rewriting literal equation, and these equations are only made up of variables. So most likely than not, you will not be seeing any numerical coefficient. So let's say we have ax minus bx is equal to c. We need to solve for x, okay? So here's the technique when working on literal equations, okay? First thing is, what are you supposed to solve for? Which variable needs to be isolated, okay? According to this problem, we need to isolate x, okay? So this is what we need to isolate, okay? So what are we given in this scenario? So let's have Let me just change my ink. Okay, so you're given AX minus BX is equal to C. Our goal is to isolate X, okay? So, a lot of people get confused. They are all numbers, they are all letters and stuff like that. You don't have to worry, because whatever you do with numbers, you can also do them with variables, okay? So if you're going to take a look here, our first step is we want X to be isolated. But as you can see, we cannot combine these terms. Well, technically we can combine these terms since both of them have the X variable, okay? So if we combine these terms, if you're going to use combining like terms, you will have A minus B, whatever those numbers are, and it will be X as the coefficient. So for example, if I have, to better explain this, so let's temporarily put in some numbers in place of A and B. So for example, if you have 3x minus 5x is equal to whatever. So what you do to combine is you actually have the 3 and then the minus 5, which is negative 2, and then you just apply the variable X, right? But like I said, right now, what we have are variables. And so what did we do here in reality? We subtracted the first coefficient by the second coefficient. And so in our case here, it's A minus B, whatever that value is, and then we attach the variable, which is X, which is similar to what we did here, okay? So equals C. Now take a look. What operation is involved with the quantity A minus B and X, okay? If you're going to analyze very clearly here, you have a multiplication on this particular example. It's actually the quantity A minus B times X. And what do we do when we need to isolate the variable? Remember, we can isolate a variable by undoing the operation. We have to use the inverse operation. And what is the inverse of multiplication? It's going to be division, okay? And so, for us to get rid of the A minus B quantity, okay, we will divide everything here on the left side by whatever that number is, which is A minus B, correct? Because once you have this divided, then we know that X is alone now. Now, remember, we have the properties of equality, and so we also have to divide A minus B on the right side. Do we have our variable isolated now? Yes, actually, X now is by itself. And what is it equal to? It's going to be equal to C over A minus B, okay? So this is now, so the value of X is not a specific number, but it could be replaced. You can use the value of X by getting the representations using these variables. Imagine that they are numbers. What did you actually do with it? Okay? All right. Let's have another example. So let's see this next one. Try this one on your own. We have negative t equals r plus px, and we need to isolate x by itself. Go ahead, try this one out. So again, as you can see, we need to undo addition first. And so we have that minus r. And so that will leave us with px. We only want x to be alone, so we have to undo the multiplication. And so the value of x using all the remaining variables will be negative t minus r equals p. Okay? So this last example, try this one on your own. This time, y needs to be by itself. Go ahead, try it now. Alright, so just like our previous examples, you gotta make sure you know which variable you have to isolate. In this case, it has to be y. So what you can see here, you have like terms, both of them have y. So basically, we just have to add s and q together and multiply it by y. And we want y to be by itself. So as you know, there is a a multiplication happening in here. So we divide, we undo the multiplication, and so y is going to be equal to x over x plus q. Okay? Thank you.